This tutorial follows on from my basic inventory tutorial. I recommend watching it if you haven't already. It's only 8 minutes long. Today we're going to add basic mouse control in the sense of being able to drag items around the inventory. If you can do that, then working out how to use or discard items with the mouse is also very simple. You'll remember our various inventory functions. Well, we're going to add one called inventory swap. This is what we'll use to commit to finally moving an item from one slot to another, including just moving an item to an empty slot, as that is still effectively swapping the contents. We get the root inventory object we're moving from and the one we're moving to, and the slot we're moving from and the slot we're moving to. Obviously, in the case of just moving between the slots of one inventory, object from and object to will be the same, that's fine. We get the item we're moving and we stick it in a temporary variable. We access it by getting the ID of the inventory object we're moving from, the array of slots in that object called inventory, and the slot number we're moving from. Then on the next line, we can safely set that slot to be whatever it is in our destination slot, and set the destination slot to be whatever we stored in the temporary variable. Now, whenever we call this, we can swap the contents of two slots in two inventories, or two slots in the same inventory. Now we can start on the actual mouse control. To do this, we're going to make a new object called oMouse to handle all of our mouse interactivity. It's very easy and tempting to write mouse behavior all over the place, wherever and whenever you happen to need it, but from experience, I can tell you this gets extremely messy. You can end up with lots of overlapping behaviors and find yourself needing to write lots of awkward conditional branches to cover, like trying to right click on a menu button while you're dragging an item, and some other interactive object is like also under the menu button, and so on and so forth. So we're going to make a new object and immediately stick it somewhere in our room so we don't forget to do that. The create event is where we're going to write most of the code, as we're going to use a state machine for the mouse. If you don't know what that is, it means we're going to write some functions in our create event, and then our step event is going to pick between those functions based on what state the mouse is currently in. Again, this is just to help us isolate functionality, because you might want the mouse to do lots of different things in a game. If you want to learn more about state machines, I have a 4-minute primer video. I'll put a card in a description link. Anyway, first of all, we need some variables. These are fairly self-describing, but they're going to contain the inventory object and slot that we're hovering over at any point, the inventory and slot we're dragging at any point, and the specific item type we're dragging so that we can draw it later. The first function we're going to make is one that will be common to a lot of states, and that's the mouse over function. We want to check if we're hovering over an inventory slot. Any mouse interaction we have with the inventory is going to rely on this in some way. First, we empty the contents of slot hover and inventory hover, and then we get our mouse coordinates. I don't know if vars are actually faster than referencing mouse underscore X and Y, but it sure makes the next chunks of code a lot easier on my eyes and quicker to type. We use a with as an easy way to iterate over every inventory object we happen to have. With is really good for that if you don't care what order you do the iteration in. We then check to see, first of all, if the mouse is over the inventory at all, because if it's not, we don't have to go through and check every slot. I've used the same maths here as I used to draw the inventory box in the first place. If you stored this stuff in variables with less magic numbers, then you can obviously use those. If the mouse is here, we look to see if it's inside any of our slots by checking them each in turn. Again, using the same maths and same kind of for loop we use to draw each slot in the right place. There's probably some fancy maths you can do for this check so you don't have to do this loop, but with there being space in between each slot, etc., it seemed a bit tricky, so I went for something simple. The performance cost here for a long for loop is super trivial unless you have like 1,000 slots, then you might need to get fancier, but never spend loads of time optimizing until it's really necessary to do so. Rectangle checks are not that expensive. Anyway, if we find a slot that our mouse is hovering over, we assign that slot to slot hover, and that inventory object to inventory hover. Remember that you're in a with statement here, and the code is running from the inventory object itself, so you have to include the other at the start of these assignments to set the variables back in the mouse object. Then we close 100 brackets and we're done with this function. This was the hardest part of all of this really, and it just uses maths that we've done before in order to draw the inventory itself. Then we can fold this away by clicking the little minus here, or we can just scroll down because we're going to create two states for the mouse. State free and state drag. Let's look at state free first. We call the mouse over function we just defined to see if we're hovering over anything. Then if we click the mouse button and we are hovering over a slot, and that slot isn't empty, we can enter the drag state. We change our state variable and assign item drag, inventory drag, and slot drag appropriately. Also, I know we haven't defined this state variable anywhere else, but we do that at the end, so don't worry. Then in the drag state, we again check our mouse over status, but now we check to see if we're no longer pressing the left mouse button. If so, we're in the drag state, so we must have an item to try and drop. We make sure we're hovering over a slot, and if we are, we run inventory swap, providing the inventory and slot we're dragging, and the inventory and slot we're hovering over. Then either way, we return to the free state and we empty those drag variables. After we've defined all of these states, we need to initialize the state variable, so we set it to state free at the bottom. Once we've done all this, we add the step event and we simply write state, open bracket, close bracket, semicolon. That simply means every step event, we're simply going to call whatever function is currently in state. That is, whichever state our mouse is in, state free or state drag. That's 100% of the logic, and it will work, but it won't feel very good. It won't be super clear when we're dragging or if we successfully clicked on something. The first thing we can do is add something like this to the draw event of oMouse. If we have an item type currently being dragged, draw it semi-transparently at the mouse cursor. But we can go further than that and use all those helpful variables we defined in oMouse to tell the inventory objects to draw highlights on hovered slots. First, you want to have an extra frame in your slot sprite that will represent a slot when it is moused over. I just gave mine a white highlight. Then in the draw step for oInventory, we make a couple of tiny changes. We put a 1 or 0 into a variable based on if we're hovering over this inventory and we're about to draw the slot we're hovered over. Then we use that 1 or 0 to draw the correct frame of S slot. Now we can see which slots we're hovering over. When we draw the item in the slot, we can use the same kind of check to see if we're currently dragging that slot. If so, we can set our drawing alpha to be 0.5 so it will draw the item semi-transparently. Now things look a lot better and it's much clearer what we're doing. There's plenty more you can do here, of course, but that should be enough to get you started. Thank you to my patrons for selecting this topic and funding this video, and thank you, of course, for watching. I hope you found this helpful, and I'll catch you all next time.